Good morning, everyone. This is Allie Mastardo. I am the Senior Association Manager of PPRA. Thank you for joining us today for our webinar on offering pavement management as a professional engineering service. We do have you all on mute for the webinar, and we'll be using the question function on the sidebar of your screen for any questions. This webinar is being recorded, and a copy will be provided to all registered attendees via email and will be posted on roadresource.org. I would now like to welcome Lindsay Matoush, CEO and founder of Vario, who will be facilitating today's webinar. Vario is the marketing firm that partnered with PPRA to create roadresource.org. Lindsay?
Good morning, everyone. We are excited about our webinar today and the lineup that we have for you. It's a unique webinar coming out of PPRA and Road Resource. Really, the star of the show today are two incredible advocates for roadresource.org. We have Peter Robleski from Howard Stein Hudson. Peter's a civil engineer licensed in California, Massachusetts, and Tennessee. He's currently a highway design project manager at Howard Stein Hudson and has previously worked as a pavement construction inspector, a pavement network manager for the County of Santa Barbara in California. He was introduced to PPRA and roadresource.org at an ISSA slurry systems workshop in 2017, and since then he's been a supporter of Road Resource and one of our most active advocates from the consulting engineering team. Art was a civil engineering graduate from UConn. He began his career for 9 years in heavy highway construction as a project engineer on sizable $50 to $100 million projects in Boston for the MBTA and the Central Artery Tunnel. He then transitioned to the public sector as a public works director in both Connecticut and Massachusetts for 11 years before joining Indus in 2014, where he spearheads their sales and marketing team. He is really passionate about pavement preservation and the benefits that it provides to clients and taxpayers. So excited for you guys to hear from them today. From my seat, Vario has been partnering with Road Resource for the last since 2015, and so we have a chance to talk to agencies all over the country, and we regularly hear how important consulting engineers are in the pavement preservation and network management conversation. So it's out of quite a bit of demand that we designed today's webinar, just so you know who it's coming from. If you're not familiar with the Pavement Preservation and Recycling Alliance, it is a partnership between EMA, the Asphalt Emulsion Manufacturers Association, ISSA, the International Slurry Surfacing Association, and ARA, the Asphalt Recycling and Reclaiming Association. They came together in an industry partnership to form the Pavement Preservation and Recycling Alliance. The single goal for PPRA, for Road Resource, for anything you ever see coming from us is this: we empower agencies to be the best possible stewards of their road networks and their taxpayer dollars. So today, kind of three sections to this webinar. Number one, the role of consulting engineers in pavement preservation. What we hear a lot is from consulting engineers and even from agencies, what role can they play, and how do we make sure consulting engineers have all the tools that they need to be confident in recommending the right treatment plans to agencies, and to make sure that they're not leaving really important tools on the table. We'll talk about preservation and recycling in action. Art will share some real world examples of what it has been like to help his clients make different decisions that stretch resources further. And then we'll talk about utilizing roadresource.org, and we will share we'll share some resources with consulting engineers so you all know where to go for more. So before we go any further, I'd love to do a quick poll and find out who is in the room with us. Just click one of the options on your screen. All right, we'll go ahead and close that out. It looks like we have about half the room is consulting engineers. We've got, there we go, a little under half, about 40% from the municipality or DOT world. So many of you, so consulting engineers, I expect you to be able to take away a lot of really great free tools, inspiration, ideas from what I think are some of the best in the business at figuring out how to help agencies stretch their resources further. Municipalities, DOTs, if you are working with consulting engineers, you will take away just what you should be able to expect from them and how to work with them on projects in different capacities. And then our contractor suppliers, manufacturers are often a part of those partnerships and are kind of spearheading that. So great. Here's what we see. So again, in the industry, we have interviewed literally hundreds, if not 1,000 agencies around exactly this conversation of preservation, recycling, network management. How do you move the needle? How do you reverse deteriorating network trends? And here's kind of what we are seeing. Number one, America's infrastructure is failing. Number two, the only way up for most agencies is network level planning that utilizes pavement preservation and recycles the resources that you've already paid for. Most agencies aren't getting a lot more money to redo their roads, and the only way to see infrastructure improve is through this network level planning. Number three, agencies trust consulting engineers to direct their resources wisely. I have been at numerous tables with agencies who just do not have always the expertise in-house to be able to design all of this work. And so they're really leaning on the wisdom, advice, and expertise of their consulting engineers. And so what that means is really consulting engineers have the opportunity and the responsibility to advise agencies with excellence. Add to that the rise in the asphalt cement price history over the last several decades, and it makes the ability to stretch resources further even more important. So we'll talk a little bit about the role of consulting engineers in pavement preservation, and to do that, I get the pleasure of introducing Peter Robleski.
Thanks, Lindsay. So as Lindsay mentioned, my background, I was a pavement network manager for a county in California with about 1,500 lane miles. And since then, I now am a project manager on roadway design projects. And when I started my new role, I was really looking for a way to impart some of the knowledge and experience I gained in that network management, pavement network management role. And that's what I really want to talk about here today. One of the first things that Lindsay touched on is why we think consultant PEs belong at the table. The three keys that I kind of see here are reputation, money, and time. The reputation is usually consultant engineers, PE engineers that are verified and vetted by the state DOT, usually are pre-authorized designers, have been through a regular process. This is a group of people that have reputation in the industry of being the professionals who know how to build roads that'll last. The second one is money. Most of the money in public infrastructure ends up going to large capital projects, new highways, new roads, new bridges, lots of new infrastructure. And there isn't always a lot left over for maintenance. Local agencies are often scrambling to find maintenance dollars, as I think everyone on this call is aware. So are state agencies, and it's a problem that continues to grow as a collective, as we continue to neglect our maintenance needs. That backlog is going to grow larger and larger. And if there's money available in the capital projects and the capital program and new roads, then it makes sense to try to utilize some of that to make sure and ensure that we're building good roads that are meant to last and try to help solve that maintenance backlog problem. And the last one here is time. You know, it's the same reason that consultant engineers do a lot of the design on the state highway, federal roads, you know, large scale bridges, all of the big infrastructures that, all the big infrastructure projects that happen, excuse me, are usually designed, at least in some part, by a consultant engineer. And that's in large part due to lack of time for the owner. Some of the best designers, engineers, resources, experts work for local agencies, for public owners, and we're not saying to replace them, but unless that person already exists and is doing this role on every project that goes through their agency, there just isn't enough time to check the pavement maintenance and long-term pavement management processes on each of these projects. So after going through there, I think the next question I've got for you is another poll. If you are a consulting engineer, please feel free to chime in here and just choose one of these options. Trying to look and get a litmus test of how much pavement management best practices do you do in your role as a consultant engineer. And Lindsay or Allie, I can't see those poll results, so whenever you've got a good number, feel free to close that out. It's something that usually is included on each project, whether it's large scale, small scale, if you're doing minimal amount. There we go. Okay, so it looks like it's an important and growing part of everyone's practice that's here, but pretty split across the board between the other three results. The small part of our practice applied on projects but not networks, and we don't do anything yet. So that's a good cross section of who's here today. And I think if we move to the next slide here, this is what I believe most people think of when they think of pavement management and pavement preservation consultants. And I'm not going to read you all these bullets. There's a lot of information here. But essentially, there are specialty consultants who do pavement preservation practice, and they do a very good job. You know, they'll go take their trucks with their LiDAR and their different ground penetrating equipment. They'll do IRI deflectometers and cores, and they'll walk the corridor and get a survey of all your road conditions. That's excellent work. And that's not at all what I'm saying your firm should be focused on replacing. It's a critical part of pavement network management, but it's above and beyond what I think is the expectation that I'm trying to offer up as an additional service here today. If you're interested in this type of role, you know, there are definitely companies out there. If you're an owner, if you're a DOT, these services exist. I think if you're a DOT, you probably are already using one, but it's not the ultimate goal of what we're looking to accomplish today. What I'm looking to accomplish today is to help that first step. When you're working on a project level as a design consultant, how can you incorporate best practices, pavement management on your already existing projects? And then, you know, hopefully, if you've got a local agency, an owner client who's interested in that network management, and they know you did this good pavement preservation on a couple of their big projects, they'll look to you first when they need to develop that. So on the next slide here, what I will be talking about today is the role of a consultant engineer on a single project. And if we kind of break it down to be the beginning, middle, and end, right? Before the project starts, how does this work? What should your consultant engineering role be when you're designing a highway project? If it's a major reconstruction, if you're doing a realignment, if you're doing new geometries on several intersections, the design for the roadway structure can be a little bit of an afterthought. And what you can do to help mitigate that is to do some pre-design investigative work. Look up and see what records are out there. You know, most maintenance organizations keep pretty good detailed records. If you can't, for whatever reason, if you can't go get pavement cores, which please go get pavement cores on every project every time, it's the cheapest insurance you can get. But if for whatever reason you can't get pavement cores, look at the record data. There's, you know, if you can get a record of when this road was last treated and what was applied, that's really key information. If you can get a construction record of when the road was initially built, that's really helpful. And you can kind of piece together a historic record of what we think is out there, what our best estimate is. You can, in some of these roads, if you're reconstructing it, you might be able to go take a core sample by picking up one of the big chunks out of a pothole. And I know I've done that a few times when we're walking the roadways. Even if it's on the edge of the road, a piece is raveling, you can get a pretty good idea of the last time that road was overlaid and see what that top surface thickness is. The reason this is so important is because it's going to impact the rest of your design. If you're going to follow typical roadway design, be it by the DOT, the FHWA, you know, Green Book, whatever protocol you're following to do your pavement design, there's an opportunity there that either you're missing out on some serious savings, or you're over designing, or that you're under designing. And we'll talk about a couple of those examples coming up. But that initial investigation is critical. You got to get out and see the road, take photos, take pictures, take cores if you can, but just collect that data as part of your project startup. And then during construction, what can you do? Well, one of the things here, it says that you can see what local standard details need to be used to be included. What I'm talking about there is what level of survey, what level of cross slope direction do you need to include? If you're doing a simple overlay on a project and you're gonna put in a quarter crown and mill off at the edge of pavement and zero out, yeah, you might not need survey. You might be able to build up on the crown. But if you're planning on doing any sort of changing the center line or changing where changing from a super elevation, identify where that survey is needed. And that's a key role of a consultant engineer. It might be something that based on the maintenance crew who's doing the work, maybe it's something they do in-house all the time and they've never had a survey and they do great work and the roads come out awesome. Wonderful, then you can work with them and figure out the best way to approach this. But on a typical project, we would go on one of our designs, we would get subsurface, we would get the surface drawing, we'd get, typical topographic survey. And that might be overkill, but your role as a consultant engineer, when you're from a pavement perspective specifically, is to identify what survey needs you have from that pavement design. And then after, there's a couple cool things you can do as a deliverable, a product deliverable for your client. One of the big ones is you can make a maintenance plan a requirement of the contract. You can have it be where the contractor, after 2 years, there's typically a warranty. I think it's, in most cases I've seen, it's a year, but there's typically a warranty. And then you can set a maintenance plan to extend beyond that. The contractor doesn't have to be the one to do it. It might be tough to keep them on the hook for the next 5, 10, 30 years. But at least if you establish this plan and put it with the DPW maintenance group and make sure they're aware of what you've identified as the maintenance plan for this road, even if they don't use it exactly to the letter of the law over the next 30 years, that's going to be such a key asset for them to identify their future costs, to identify their future backlog, and to help identify what that expectation is for them to maintain this brand new asset. And it's, again, these are all things that you're either already doing them as part of your project or they're pretty cheap ads on your part. And so on the next slide here, I'm going to talk about a specific example. So I know this is going to be a little bit small on your screens, but I really wanted to show 2 things side by side here. The purple area you see there, that's a project that we recently did in Newton, Massachusetts. There's the main road and then a carriage road. And that's something where, we have the mainline traffic. The carriage road traffic also is for vehicles, but typically just for people going to their homes. It's side streets and the through traffic goes on the main road. Our project was to redefine these uses. The primary goal of the project was to make the carriage road a shared use path and a bike path. And one of the first things we did when we went out there was check the pavement condition. And it's going to be hard to see on the detail that it is on this plan, but if you got a chance to zoom in, there's a few different color-coded areas on that plan view of the carriage road. And you can see the purple and the blue. And then what we did is we kind of highlighted those areas in different colors to exemplify what the different types of stresses and failures are that we saw when we went out to the road and looked at it. And I can't remember if I took those pictures or my coworker did, but those are the photos of those areas that correlate to those failures. This was a really helpful first step for us to identify what's going on in the pavement and how are we going to correct it. And at the time, we were just doing our due diligence. We thought it was best practices to include this scope of work, and it wasn't with any foresight of what the ultimate design of this project was going to end up being. And on that second photo there, you can see one of the pavement cores we got. And that's only 2.5 inches if you're rounding up. That's right in the middle of the carriageway. And that is on top of native material. The native material was pretty good material. I mean, they built a road on it and it held up for a little while. So it was a solid base course. But the issue we had is if you're going to mill and overlay a 2.5-inch section, well, how much are you going to mill down? Because if you go more than an inch, you're going to just be left with a crumbling mess of an existing quality that's already poor. And any construction traffic that hits that is going to just really tear it up. Now, I'm showing the thinnest core sample that we took, and there are definitely some that were 4 and 5 inches, but it's a good example to show that we found failed areas that were out there. And a key strategy that I want to highlight here is when you're taking your cores, where do you take them? Try to take them on the cracks, try to take them on the failures. If you do a heat map like this, whether you produce the actual heat map or not, when you go out and see different types of failures, if you see rutting, take a crack in the rutting. If you see a long longitudinal crack, take a core there. You want to know what's beneath those cracks and try to identify the source of those failures. And on the next slide, we've got, so this is the cross-section view of that carriageway. And the cross slopes don't matter too much here, but what I really want to highlight is that MWRA 60-inch cast iron pipe right in the middle of our plans. So because of this cast iron, MWRA is the metropolitan water, we really had to keep a high clearance above that. We ended up having to do some structural counts and did some soil testing. And I think our minimum clearance had to be a foot above that pipe, but for us to do any sort of construction. And with that close shallow pipe, it really limited what we were going to be able to do in terms of addressing this problem. So, the typical response would be a full depth construction. That's a failed surface, and you can't rely on those aggregates. Just calculate your structural number and go put out 6 to 8 inch road with 6 to 8 inches of aggregate base, whatever that's going to be. But clearly, when you do that, you're going to be impacting that cast iron pipe. And the way that the MWRA works, they really, really were going to fight us if we got anywhere close to it. And we didn't want to either. We were trying to avoid that. So just with my background, I went to roadresource.org, which is something we'll talk about here, and checked what I thought might be a good fit was a cold in place recycle. And for those who aren't familiar, a cold in place recycle is a long train process where the milling machine essentially, and it's more complicated than this, breaks up the asphalt, blends it together on site with some new asphaltic emulsions, and then paves it back in place so that live traffic isn't driving on the exposed grinded course. You do have to cap it with HMA. It's not something that you want to leave as a surface course, but it eliminates the need. It kind of helps increase your structural number, especially if you're considering it part of the aggregate base rather than part of the HMA structure. So on the next slide here, I'll show you some of the considerations we made when that happened. The cold in place recycle is the option on the left. And the first steps there, for my own confirmation, before I suggested this to anybody, I went to roadresource.org and looked through their examples, and Art will get into some of those details a little bit later of what the website's like. I also contacted Art. He's the person that helped me out with this and got his opinion on what he think might work here. And he went out and took a look, and we looked at the project together, and he came up with some ideas. And then following that, I contacted the state pavement office and talked it through with them and made sure they were supportive of this idea to really get buy-in before we propose something new. This is not something that I felt comfortable, figuratively or literally stamping with my seal of approval without that buy-in from all the stakeholders. And the downside to this was we were going to have to raise the roadway profile. That's not on every project. At CIR, you can keep the existing profile in most cases, but because the existing HMA was so thin and there was no aggregate base course, it was all native, in order to get our structural number, we would have had to excavate to be within that 1 foot of the MWRA pipe. And that wasn't going to happen in our project because it kind of defeated the purpose of doing an alternate treatment. So we did have to raise the profile of the road. And that is going to be, that might eliminate some of these projects from some of these treatments from consideration in certain cases. On our project, it actually helped some of the grading and drainage. So we did have to raise the roadway profile, but it worked for us. It helped improve drainage in a few places. The reason that's red, it was a negative because that was a design cost. We had to redesign a lot of our profiles and elevations based on this treatment. But we didn't have a utility conflict. There was reduced downtime. It was way cheaper. And then the opposite of that is true for what would have been the case if we're full depth. We would have had to excavate to the top of the pipe, to within a foot. And then, I mean, I think you can anticipate the concerns we had. How are you going to protect that pipe? Are you going to put a steel plate around it? How are they going to access it for repairs? Or you end up just going to have to take out the whole thing and replace it? It was a whole nightmare of things we didn't want to unravel. And we were able to avoid that with pavement preservation. So in the next slide, I'll talk about kind of the responsibility and the opportunity that I see here. The responsibility being, you know, this is best practices. If you're designing a road that includes pavement design, you really should be looking at what that pavement design means. And there's some opportunity here for your firm to grow as well. Next slide. Oh, not that one. There we go. So how to offer this additional service. So the elephant in the room is, how am I going to get paid for this, right? How are we going to make this something that's profitable for us if we're a consultant firm? Well, some of the additional services you can offer is an assessment report and recommendation. That's something that there are a lot of resources available on Road Resource or just locally. If you talk to your pavement management office, if you talk to your local owner, the maintenance group, the people who maintain the roads really do know them better than anyone else. And so talk with them, get them to help give input, and then you can create an assessment report. It's a nice line item cost that most agencies would welcome. And I can tell you an example, one that we did where we wanted to consider alternatives to mill and overlay. We did this assessment report and we actually ended up going back and recommending mill and overlay because it wasn't appropriate to go otherwise. So you got to be honest, you got to be transparent. It's not always going to be the right fit, but the client was really appreciative that we had this detailed report to show why it didn't work to go cheaper. So they were able to go answer to their board of supervisors and say, yeah, we looked at other options, but here's the report that proves we can't do it. You can modify specs and details, and you can do an alternative pavement design, which on the next slide here is the pavement design. What I'm showing is Massachusetts DOT, and this is in their pavement design guide. There's a couple screenshots. It looks familiar to a bunch of people, I'm sure, because it's what we all learned, how to design pavement. And I in no way am telling you to not do this. This is something that you should still need to include in all your roadway design projects. However, when you're calculating these structural numbers and coming up with what your new pavement thickness needs to be, just be aware that there are options out there, and you can look and see, you know, what other treatments might apply. Do we want to save time? Do we want to save money? Do we want to save resources? If you have a client who's, you know, really cares about doing something that's environmentally friendly, there is not a material that's more recycled than asphalt in our country. And that is something that resource is on the roads. It can be reused, it can be salvaged, you can reduce trucking. There are all these benefits to it, but you still do have to do the hard math. If you're the consultant engineer, you still have to prove it. And we can get into that on the website and walk through how to do some of those things at another time, but just be aware. So the last slide here, last couple things are, how are you going to open that door with your clients? How are you going to have that conversation about adding these services? Start with Road Resource. I know I've said it like 100 times, and just be clear on what that service is going to be. And the way to start on Road Resource, you're going to get really familiar, if you're not already, with this deterioration curve. This is one that Art's team came up with, and those numbers apply to a specific location that is unique to that area. But what it essentially shows is, over time, the cost of maintaining your road. It's less expensive when it's in good shape, and it's more expensive when it's broken. And I'm going to hand it over to Art here, who can talk a little bit more about that theory and practice. And he's been really helpful to me personally on having these conversations and helping me understand. We're in the same region where we work, but if it's not Art, there's someone in your region too that you can contact through roadresource.org to help make that initial conversation a little bit easier.
Thank you, Peter. Before we get into
Before we dive into Art, we're going to do one more quick poll just to get a sense of Who in the room has used roadresource.org? We're going to be pulling from that heavily, and really the goal is to sort of say, hey, take this and try it at home, guys and gals. So go ahead and just let us know how familiar are you with road resource. And while people are voting, Peter, thank you so much for that. I really appreciate your journey into being a consulting engineer and how you've sort of really, since we first met you several years ago, been really intentional about helping agencies figure out how do we make the most with what we have and make the smartest use of our resources. Okay, so let's see what we've got here. Okay, I sometimes use it. About half of you use it regularly, 20% haven't heard of it, 30%. Cool. So if you haven't heard of it, you're going to walk away with some really awesome free tools today that should be quite helpful to you in your practice. So Art, I will turn it over to you. Art Baker, as I said in the opening with Indus, does a lot of this work with agencies, is one of the most passionate pavement preservation advocates I know, and is going to talk about, okay, what does this look like in the real world when you're helping clients to make choices and shift the way that, and many of you agencies who are here, kind of shifting how you're thinking about approaching pavement management from more of a network level mentality, not just how do I spend my budget this year, or how do I address kind of the worst roads in the network, but how do I plan proactively and stretch my dollars further. So take it away, Art.
Thanks, Lynn. And we're also going to talk a lot about selecting different treatments that may not be the obvious choice up front, and we'll get into that in a little bit. But when you look at this picture as a taxpayer, as a member of your community, you know, which side of that road would you like to travel on? I think it's pretty clear that the right side is the road you'd like to be on. I'm going to give you a couple more details about this picture in a minute, but as far as rideability, safety concerns, you know, it's definitely you want to ride on that right side, right? Here's a little blown up picture of that and tells the story. We see a lot of unique things in the public sector, and in this case, the municipal boundary between these two towns is right down the middle of the road, if you can believe it. And back in 2004, they both got together and split the cost of a traditional mill and fill project. 6 years later, the community on the right, as you can see, approached the community on the left to do a preservation treatment on the road. And they denied that project and thought it would be a waste of money. And as you can see here, we took this picture in 2019. So you have a 15-year untreated asphalt on the left-hand side and a 9-year-old crack seal and microsurface on the right-hand side. And you can see that community on the left is faced with these an expensive repair. And you can see they've already spent quite a bit of money going out and patching potholes. So this is what we're going to talk a lot about, and how to prevent that road on the left-hand side from ever even occurring. One of the things Peter talked a lot about pavement management planning, and I like to show this slide because this is one of the key elements that comes out of one of these formal pavement management plans. There's a lot of information here. I'm going to hopefully not go too quick, but for those who haven't seen something like this, there's data collection that goes on. You go out and rate all your roads, and the end result is that number you see around the dotted line, 74.79. That's the pavement condition index of their whole network. In the lower left-hand corner of this slide, you'll see how this municipality wanted to spend their available funding. And you can see there's 4 buckets. There's 4 treatment bands: routine maintenance, preventive maintenance, minor rehabilitation, and major rehabilitation. And you can see the spending percentages that this municipality wanted to make. And then the big chart going back there, what you can do as a consulting engineer is run several different scenarios, right? And the first one they run is, how much money do you need to maintain that same 74.79 level throughout your, you know, the next 5 years? And you can see that's that $1.7 million scenario. And then they also give you a couple other scenarios if your budget was to get cut, or if you had additional funding to add to your program, and what it would do to that overall condition of your network. So it's a pretty valuable slide, one that I really love, that helps the communities and helps the public works folks make better decisions. Next slide, Lynn.
Here we go.
So I'm just going to give a lead in here for Lindsay to take us to Road Resource real quick. But before we get there, on Road Resource, there's several tools that you can use to try to make these better network level decisions. And looking at the structural comparison is one of them. I don't know how often folks do it, but let's go to Road Resource right now and show you the calculator that is on there that shows the comparison of different treatments.
Thanks, Art.
And when she goes on,
and Peter, oh, go ahead.
no, go ahead.
So Peter mentioned this earlier, having to kind of add structure to a road, but dealing with the complexity of different base layers or how deep he could address distress in a pavement. So we're not going to get into any of the tools on the site in great detail, but for many of you who haven't heard about it or who only sometimes use it, we want to make sure that you have some of these tools at your fingertips. So many of you are often dealing with a scenario where you've got to add structure to a road, and there's different ways of approaching it. We encounter many agencies and consulting engineers whose kind of go-to or default treatment, as Peter talked about, is a mill and fill. And often it's just not the best or the most efficient from a cost perspective way to add structure to the road. So this gives you several examples and then a calculator to play with. I'll just show one of them here. This is an example of a road that has deteriorated to a structural number of 2.16. And what we're comparing on this about page is what happens if I want to do, how am I going to add structure to this road? What are my options? Well, on one side, I can do a more conventional mill and fill. And you can kind of see here what I'm doing with different layers of that pavement or that base, and what kind of contribution each of those layers is creating or generating for that overall structural number. So if I were to do a conventional mill and fill, my cost for that would be $16.95. This is a national average. That's really not relevant to anyone, but I'll show you in just a moment where you can put your own costs in here. And that would generate a structural number of 2.88. Whereas if I look at a cold in place recycling treatment, you can kind of see how we're addressing different levels of the pavement of the base there. And my cost is $10.35, so significantly less, and actually generates a higher structural number. There's different examples here that compare HIR versus mill and fill, FDR versus reconstruction, and then kind of a hybrid approach. And then you can go to the calculator here and you can explore that. You can actually put in different layers within that pavement structure and compare that to recycling models and sort of see what's available to you. You can change the cost in these boxes here to be what you're actually experiencing in your area, or if you go ahead up to the top here and you create a login, the website will allow you to populate every calculator tool on the site with costs, life extension, and structural contribution that you are experiencing or assigning in your area to make all the data and tools on the website much more relevant. And this tool can be found right here under the recycling section on Road Resource if you have not been here before, and under the structural comparison calculator. So we wanted to kind of introduce that concept, and then Art is going to show you some real world examples of how he's helped agencies make decisions using exactly this line of thinking.
And I was very happy to see it looks like about a quarter of the attendees are using Road Resource fairly regularly. I can honestly say if this tool was available and out there when I was a public works director, it would have made my job so much easier. So for those folks who are not familiar with it, really check it out after. It's really a great website. So basically the information you see here, what this does is, I sat down with a client one time who was considering doing a mill and fill, but they wanted as much additional structure as possible. And so what I did is I put together 3 scenarios for them based on these structural numbers that you see in Road Resource. The first scenario is the top one where their traditional 2-inch mill and fill. So you can see in the layer levels, you see they milled out 2 inches and they put 2 inches of new hot mix in. So what's left is the 2 inches of existing hot mix. And then, of course, an 8-inch granular base underneath it is what we were assuming. If you go to a materials book, you go to roadresource.org, you can see the coefficient number for each of those layers. So for new asphalt, 0.44, for existing asphalt, 0.2, and for granular base, 0.1. And again, those are average numbers. If you actually went out and did some material testing, you know, they may deviate up and down a little bit, but those are fairly decent average numbers. And then, of course, to get your structural number for the layer, you're just doing simple math by multiplying that coefficient by the thickness of the layer. So 2 inches times the 0.44, you can see gives you the 0.88. And I won't go through all that other math. I don't think we need to take the time to do that, but you can see for a 2-inch mill and fill, you end up with a structural number of 2.08. Now let's say you can raise the elevation of the road and we're going to recycle the 4 inches that's there with cold in place recycling. So what happens here is, again, you have to be able to raise the elevation of the road because we're not going to remove any material. And if you look at the coefficients there, the CIR layer goes to a 0.36, not quite new asphalt, but fairly close. When you do all that math, you get a structural number of 2.9, which is about a 40% increase in the strength of that road. Now, let's say like in Peter's situation where he had that project where he couldn't raise the elevation of the road, you have basically a recycled layer that goes from 4 inches to 2.5 inches with 1.5 inches on top. Do all that same exact math, and again, you're left with a structural number of 2.36, which is still a 15% increase over the mill and fill. So although mill and fill may be the initial option, if you go through these calculations, you can see that there are other options that may get you what you actually want. So if you go to the next slide, Linz. So now let's look at the cost of these, right? Structural is one, structural comparison is one, but they all have a cost. So these are rough numbers, approximate for this client that I sat with. Mill and fill, they thought it cost them about $14 a square yard to do their mill and fill. We sat down and went over some numbers for cold in place with raising the road, and that was about $18 a square yard. And then with the thinned up CIR layer, went down to about $16 a square yard. Then we looked at how long the service life would be with each of those treatments. And that's the next slide. Yep, perfect. So what we felt with the mill and fill, I've heard ranges of 7 to 10 years. We decided to take the high end for this, a 10-year service life. CIR in general is considered a 15 to 20 year permanent repair. We took the middle of the road for this one. And then for the 2.5 inch recycled layer scenario, we put it down to 16 years. And why do we do this? We want to know the cost and we want to know the service life because we want to calculate what is the equivalent annual cost. And this simple math gets you a formula that compares all these treatments apples to apples. You know, rather than just saying crack sealing is inexpensive and full depth reclamation is very expensive, you know, how expensive are they over the life of the treatment? And so as you can see in the simple math, you just take the cost of the treatment in dollars per square yard, divide that by the life extension in the number of years, and you're left with that equivalent annual cost in dollars per square yard per year. So if you go to the next slide, Linz. Lindsay will now take us and show you, before we get to our example, she's going to go to Road Resource and show you the calculator that is in there. She'll kind of walk through the treatments, and I'll just kind of explain it. So you can see it's a chart, and you go into the treatment type and choose whatever treatment that you're looking for. In this case, Lindsay's going to go from basically the top of the deterioration curve with fog seal, and she's going to go down to full depth reclamation. And you can see as she does that, it puts in the cost per square yard, puts in that life extension we just talked about, does your calculation for you and gives you the equivalent annual cost. And then in addition, it gives you this nice little bar chart on the right where you can actually visually see how much more expensive it gets as you go down the curve. And again, I just want another real quick statement about the cost per square yard and the life extension. When you sign up for the website, which is a free website, you want to make sure you update those to reflect those numbers in your area. So now let's apply that concept, equivalent annual cost, to our examples. So we said the mill and fill was about a $14 a square yard treatment, and we're going to get about 10 years of life out of it. So you do that math, and it's $1.40 per square yard per year. Now let's go to the CIR, which we said was a more expensive treatment, right? $18 compared to the $14, but now you're going to get 18 years of life out of it. So you do that math, and it's about $1 per square yard per year, which is 40% less expensive, or the mill and fill becomes 40% more expensive than the CIR. Go down to the last scenario, and again, very similar, right? $16 a square yard. We cut the life down a couple of years, and you're right about the same dollar per square yard per year. So again, just to show you another tool for you to use when you're considering what treatment to do on what type of road. If you're looking for structural increase, you may want to consider other treatments than mill and fill.
I love this example because when Peter was talking earlier about really having that mentality of how do I save clients money and how do I build those partnerships for the long haul that are based on trust. because they know I'm going to do the right thing for their roads and their dollars. And these are just some really cool tools and a great real world example of what it looks like to be able to think not just about cost upfront or default treatment, but what's the right strategy for this road and what's the right way to plan for the various things I'm balancing between cost and life and structure.
And so here's another real life example, and just to show you the difference between waiting for your roads to get bad versus having a proactive approach in taking care of some of the roads. You know, a good pavement management plan prevents roads from falling into the next treatment band. You saw those 4 treatment bands we talked about earlier. A good program takes care of some roads in each of those bands so that you prevent them from falling into the next expensive band. And so for the city of Warwick, Rhode Island, they have a very big network for a municipality, 348 paved centerline miles. We considered an average width of 28 feet wide. So they're looking at a network of over 5.5 million square yards that they have to maintain every year. And if they waited for the roads to get bad with this worst first approach, we used $1.40 for the EAC, which is in between recycling and full depth reclamation. They would need over $8 million to make that program work. And I don't think any of us have that kind of money to maintain the roads. So now if you went and take a preservation approach, for the next, if you hit the next slide, Linz, you'll see for that same network, now we used a 60 cent per square yard EAC, and that's basically a surface treatment. And you can see they need less than half of the money. Now, of course, this considers, you know, that every road you have is in that category. Obviously, like we've talked about already, it's a mix, right? It's a mix of doing some roads in each of those treatment bands.
Hey, Art, I just want to comment there because I know what some of the consultants on here are thinking. If you're considering your billings as a percentage of total budget, you know, 10% of 8 million looks a lot better than 10% of 3.5 million. And that's not the case. It's limited funds. So you're not undercutting your own fee here by advocating for more efficiency. And I know that's intuitive, but I just want to say it to be clear that there's a way for everybody to win across the board when you're more efficient with your funds.
Good point, Pete. Very good point. All right, I'm getting short on time here. So the last concept I want to go over with you, that's another great one in roadresource.org, is remaining service life. For those who haven't heard of remaining service life, it's a very, very, very good message. And I am 100% convinced if we could all learn how to convey this message to our decision makers, our taxpayers, our decision makers, you know, on the Board of Finances and select boards, we'd be able to accomplish what we want to accomplish with the available funding we have, and in a lot of cases, get more funding. So the concept, simple. You take the miles that you treat, you multiply it by the life extension for that treatment, and what that is that's the number of new life in mile years that you inject into the network. So let me just quick example. Let's say you did 10 miles of crack seal that you thought had a 2-year service life. 10 times 2 would be 20 mile years of service life that you injected into that network.
So I'll walk through how we think about this on the website on roadresource.org and some of the tools available to you guys to try this on client networks or on your own networks if you're an agency. So, and this is I think this is one of the most powerful tools that the website, if you're not familiar with it, has over 500 pages. And before we hop off, I'll take you through some of the big block sections of the site so you know it's available to you. I think this is one of the most powerful tools and a great starting point if you are just learning about network level thinking or you're really trying to assess progress, because it's a way of looking at your treatment plan for the year and then asking the question, does this treatment approach for the year add life to my network? Am I going to start that up into the right trajectory, or am I going to continue to contribute to a network decline? So if you go to the website under network optimization, there's a lot of tools here. If you're not familiar with it, you go to about for remaining service life, and that's where we are. So here's the, and this all comes from a resource published by the FHWA, and you're welcome to kind of check that out here. But here's the idea. As Art was talking about, we think about mile years of life that I am injecting into the network with my treatment plan each year. And so the idea is to know that a 500-mile network loses 500 mile years of life annually, because every mile in that network is going to deteriorate 1 year, every year. So then the question is, if I have a 500-mile network, or in the example that we're going to walk through, a 1,000-mile network, am I adding or subtracting life? So you see here is kind of a tale of two agencies. On the left, a worst first approach, you can kind of see that by saying, well, look, all their money, so both agencies are spending about $4.6 million. On the left, this agency is spending almost all that money at the bottom of the curve in those most invasive treatments. They're doing 9 miles of reconstruction and a full depth remove and replace. They're doing 16 miles of rehab, mostly mill and fill, and 0 preservation. And what's happening for them is 567. So they spend all their money. They only inject 433 mile years of life into the network. You can see how that adds up here. And so their network is going to lose 567 mile years of life that year. On the right, you see what happens with an optimized approach. So what this agency says is, hey, you know, instead of fold up and remove and replace, I'll fold up and reclaim 4 miles. And instead of 9, I'm going to do 4, because 5 of those miles have already failed. And if they're not a danger to the public, I'm just going to let them fail, and I'm going to borrow that money to spend it higher up the curve. Then when it comes to rehab, I'm going to do half the rehab I was planning, and instead of a mill and fill, I'm going to do some recycling. Now where mill and fill is appropriate, I've kept that in here. And then with the rest of the money, I'm injecting it higher up the curve in those more efficient EAC, equivalent annualized cost treatments, to sort of inject more life into the network. You can see what a treatment plan would look like here. And for the same amount of money, this agency is actually gaining 100 mile years of life. There's a calculator right here that allows you to show, oh, okay, if I were to do, you know, 10 lane miles of chip seal, what does that add? Or crack seal, excuse me. Microsurfacing, what would happen if I were to do 5 miles of microsurfacing? You can plug in your budget up here, and then you can compare the overall impact of mile years of life added of different treatment plans before you get into it. You're able to export any of these calculators into Excel to play with on your own time. And just remember, if you have logged in and created an account, all the costs will be customized to you. So that's remaining service life, and really one of the most powerful tools. But let's have Art take you through a quick real world example.
Yep. So this is another real world example, a 90-mile network. So more at the municipal level, obviously. List of treatments on the left, the life extension associated with all those treatments in the blue column, the cost per centerline mile in that next column. And then I sat down with this client at the end of 2022, and this is what their program consisted of and what they did. They did $50,000 worth of crack seal, which they were able to do 5 centerline miles, as you see in that next column. So when you do that remaining service life math, 5 centerline miles times the blue column, the 2-year extension, it gives you 10 mile years of life that you added. And then they spent the rest of their money down at mill and fill. $805,000. They were able to do 4.6 miles. So do that math, 4.6 times the 10-year life adds 46, for a total of 56 mile years of service life that they injected into that network. Now the bad news, of course, now you have to subtract off that 90, which is their total network. And when you do that, you get a net loss of 34 mile years of service life. And I just like to track at the bottom. This is something I do on the side in that yellow, is what percentage of your treatments are coming, or what percentage of the new life that you're adding to your program are coming from your preservation treatments. So those are those yellow boxes. So you can see in this case, 10 of the 56 mile years came from your preservation treatments, so 17.9%. Meanwhile, you're spending 5.8% of your available budget. So just something to keep in mind as you look at these numbers. So then I asked them, hey, what are you doing in 2023? You can see their plan there. I won't go through it. They're basically doing the same thing, except they had that one road that everybody's been complaining about. So they took some money out of mill and fill and put it toward FDR. You do that math, they went back even more. So what I worked on with them is an optimized plan. And you can see that optimized plan on the right-hand side, a fairly decent mixture of top of the curve, middle of the curve, bottom of the curve. And they didn't implement this year 1, but they are going to implement it in year 2. They did about half of that plan in year 1, half of the preservation treatments. So, you know, they're able to get there. With this, you can see they got into the green. They were able to add 106 miles, so 16 in the green. It's very difficult to get in the green. It has to be something that's sustainable. It has to be something that you don't just throw money at for a year or two and manage it on a regular basis. But you can get there. And if you go to the next slide, Linz, I think I'll end on, take everybody back to that picture you saw at the beginning of my presentation. This is that same municipality on the right. And just to follow up on that, you can see for those first 3 years, 13, 14, and 15, they went backwards every year, right? So it took them 4 years to finally get into that green. So the point is, don't get frustrated. It's not easy to get there right off the bat. Unless you get a big, huge influence of money, it's not easy to get there, but you can get there. Stay at it. I know a very good pavement manager who went from a 67 PCI to an 89 PCI in 10 years. You can get there. And the amount of money that you get every year will just dictate how long it takes you to get there. So keep plugging away, challenge yourself every day, and hopefully your roads get better and your taxpayers are happy.
Thanks, Art. I'm going to quickly, with the few minutes we have left, I want to introduce you all to just a few more tools on the site, just to kind of give you a lay of the land. And I see some questions coming in, so we'll take another 10 minutes or so after the webinar and field any other questions. So if there's anything that came up during the webinar, feel free to drop it in the chat or in the question section. I'm keeping an eye on that. Just quickly hit, how do you use road resource? Well, it's a great intro to the concept of pavement management for you or clients. It's free tools that the entire industry has sort of aligned on. So many people are using it as sort of that industry backstop to say what has contractors, manufacturers, suppliers all over the country, engineers, consultants have agreed on this as sort of an unbiased objective quarterback. It's a bit of proof of concept. There's success stories here for these types of treatments used in every client or in every climate and in every type of road. So you can really kind of learn from what others are doing and really lead the way on innovation. So just show you a couple sections on the site. Start with this treatment toolbox. Really the first thing that anybody's asking is what treatment is right for my road? And I won't go into this in great detail, but this is a criteria box that allows you to input different pavement criteria, kind of see what's happening on that road. And it will show you or gray out treatments that probably aren't an option and leave in black treatments that they might recommend. And there's a photo tool as well that allows you to select either by distress or just look at a picture of a road and then see what treatments might be possible solutions. So I want to make sure you guys know about that. And then really the big bulk of the site when I talk about 500 pages is over here in the Treatment Resource Center, where you can click on 18 different treatments. Let's say you're exploring, we talked a lot about hold in place recycling today. Say you're exploring that. Well, here's a way to look at basically what do I need to know about that treatment? What are process and variations? What's the expectation? How long can I expect that treatment to last if I'm applying it on roads in various levels of distress? And then there's really a full quality control or technical menu here that wraps with the latest research on CIR in the field or in the lab and success stories of agencies using this treatment across the country. So this is a really excellent tool. And then the last thing I want to make sure I show you guys today is right under About Us. If you want to know where we got our data, you can look at data methodology. And then for consulting engineers, I think this is probably the top tool that engineers are excited about these days. It's brand new on the website, and it is the road treatment decision matrix. So this is where you can see kind of different pavement conditions, different parameters. It gives you an idea of recommended, maybe recommended, or not recommended treatments across kind of some of those different parameters. There's also just some high-level thinking and theory here. So this is really, as a consulting engineer, a great place to start. And what we've done is kind of go through this site and kind of synthesize top content. We know it's an overwhelming site, and this helps you kind of know where to start. The last thing I want to do is just mention, if you are interested in learning more and kind of staying connected to what's happening, both ERA and ISSA that I mentioned in the beginning, the Asphalt Recycling and Reclaiming Association and the International Slurry Surfacing Association, have memberships for consulting engineers. These are much more efficient memberships than if you were joining as a full member, but they allow you access to all of their resources in addition to the free ones on Road Resource. And then this is probably the best place to go to learn more. It's the Road Resource Network Boot Camp. It will come again in spring 2024. It fills up quickly. So if you are interested, we do a 3 days, 2.5 hours a day. You get professional development hours for it. And it's really a great place where we will teach all of the calculators and tools on the site, really interactive session. And it's a great place to learn more. So go ahead and email roadvaquette@hellovario.com if you want to get put on the list to be notified when we open up the next class. And with that, I'll field just a few questions. So first of all, let me just say thank you so much, Art and Peter, for sharing your knowledge today. And we've had a few questions come in. If we don't get to all of them, we'll email out answers. First question is a more technical one. Do you recommend diamond grinding for ride quality remediation of asphalt pavements?
I don't know, Art, if you have an answer on that, but I've only used diamond grinding for sidewalk for trip hazards. I would use micro milling or fine milling, but I haven't seen diamond grinding for a roadway. Have you?
I would agree with that. More concrete related, micro milling helps bring back the profile on the roads for sure.
Thank you. Art, were you able to project the PCI of the network from the RSI calculations?
So that's a great question. The answer to that right now is no, but I do know there's a few consulting engineers out there that are working on being able to answer that question. So if your RSL goes back 15 points, what happened to your PCI rating? Right now, I don't have a way to do that. I'm anxious to see the results of the research that these engineers that are working on it are doing, and that's going to be a game changer when it comes.
Thank you. And for those of you who are kind of asking, the webinar will be available online. We'll email it out. And all of the tools on roadresource.org are free, and they were built by the industry collectively to just make it easier for agencies and engineers to kind of learn their way around all of these different treatments. So with that, I know we're right at time here, and we will close out the webinar and say thank you so much again to Art and Peter for sharing your knowledge and showing us kind of behind the scenes how all this stuff works. And to those of you who are in attendance today, we appreciate your time.
Thanks, everybody.